So we're picking back up in lesson, 1.6, is that what we're on? Talking about our limits and our definition of continuity. And if you recall yesterday, as we talked about that, there were 3 parts to definition of continuity, right? And since BenQ chose not to erase overnight, I can actually go back and, if I get back far enough, we filled in this definition of continuity, right? 1, the point f of c has to be defined. We have to have a value for that, okay? 2, the limit must exist. And that's the short of saying the limit from the left, the limit from the right have to be the same. And then the third piece is that the limit, so the left and the right, has to equal the point. Okay, so those are kind of your 3 pieces for a definition of continuity. Now, on this problem, well, they actually give us 3 different c values. So we're going to do this problem 3 different times for each of the given c values. So the first time through, we're going to do for c equals -3. So we're going to talk about, is this graph continuous at when x equals -3, based on our definition of continuity. Okay, so not just saying, yep, looks continuous, or nope, doesn't look continuous, but based on our official definition. Okay, so I'm going to put the c equals -3 because that's the, that's the case we're going through right now. And as we look at this, I'm trying to think which piece I was starting with when I was doing the homework. That's what I thought. Okay, so the first piece is, if I even number these as like steps 1, 2, 3, okay, f of -3. What is the value of f of -3? Is it defined? And it is defined to equal what? 2, the point 2. Okay. So that answers our first question. Yes, there is a value defined at that point. Okay. The second piece, does the limit exist? And so this is going through and, okay, let's look. What is the limit from the left? And what is the limit from the right? So the limit as x approaches -3 from the left. What is the limit as x approaches -3 from the left? And that is -1. The limit as x approaches -3 from the right is what? -1. I'm not going to write it, but essentially that is saying the limit as x approaches -3 in general is -1, correct? So now, step 3, or part 3, is stating that where the point is defined equals the limit. And so, I'm just trying to look back at notation and remember. That's what okay. What do we know about f of -3?
Oh, no. Yeah.
It's 2. And what do we know about the limit as x approaches -3? That's a -1, right? That's a 2. So what do we know? These do not equal, do they? Okay. My point, f of -3, does not equal the limit. So is this continuous? No. And that's where we can say, therefore, we can just say, therefore, f of x is not continuous. Not continuous at x equals -3. Okay. So anytime you're asked to show, justify, prove something is continuous, those are the pieces you have to show. I mean, ultimately, the limit from the left has to equal the limit from the right, has to equal the point. That's the short of it. Okay, change it up, try it again. This time we're doing what? C equals 3. And you can go ahead and, you can look ahead and kind of already know the answer, but we need to practice how to justify it. So, if we look at C equals 3, what is f of 3? It doesn't exist. So it does not exist, undefined. Excuse me. So right there, we already know our final answer, don't we? Okay, the point is not defined. So right there, we have failed the first piece of continuity. Okay, technically, if we talk about the other pieces, what is the limit as x approaches 3 from the left? And that is, remember, this is the same graph as yesterday, isn't it? We're going to assume those are arrows because they're not points, and so this is positive infinity. Limit as x approaches 3 from the right. Well, it also goes up, so it is positive infinity. But what do we know? F of 3 does not equal the limit as x approaches 3 of f of x. Therefore, f of x is not continuous at x equals 3. Okay, repeat the process one more time. This time we're looking at c equals 7. So, what is f of 7? F of 7 is defined to be 3. I have to go across here. Oops. What is the limit as x approaches 7 from the left?
3.
Okay, also 3. The limit as x approaches 7 from the right? 6. So we got past the first part, the point was defined, but what did we find out on the second part?
There.
The limit doesn't exist, right? And since the limit doesn't exist, it doesn't even matter about the defined point, the limit doesn't exist. And so for this one, let's see, I don't even think I went as far as saying, I have it written as either way, that's what I thought. Okay, so when I get to 3, well, I almost don't even want to do 3 because at 2, we found the limit from the left does not equal the limit from the right. And you could just stop right there. The other option is we also discovered that f of 7 will not equal the limit as x approaches 7. And part of that is because the limit as x approaches 7 doesn't exist. So again, there's different ways you can say. So therefore, again, f of x is not continuous at x equals 7. And so one thing that could definitely be, included somewhere here if you want is that the limit as x approaches 7 of f of x, from the left, does not equal the limit as x approaches 7 from the right. Okay. On AP, it's not that you have to do 1, 2, 3. Okay. It's, again, as I said, the limit from the left equals the limit from the right equals the point. So if you can state the limit as x approaches 7 from the left equals the limit as x approaches 7 from the right equals f of 7, that's your proof it's continuous. Okay? Got the idea? And you do find some that are continuous. I know all three of these were not continuous, but if you think about it, they were all three for different reasons, weren't they? We're kind of showing the different options of why they might not be continuous. Okay. Confirming continuity on an interval. You must be able to confirm continuity without a graph or calculator, which is, really what we've been focusing on, by using your knowledge of function behavior for parent functions and their transformations. So basically, it's how do we figure out the whole continuity thing without having a graph to rely on. So when you're on that non-calculator part of the AP test, that we're all just going to love, right? We're all excited about the non-calculator part, about taking away that baby, right? Okay. How do we do it? So, and honestly, I feel like this right here is a pre-calc preview. Technically, it even goes back to a little bit to Algebra 2. You guys didn't really remember a lot of it from Algebra 2, but I first introduced this back in Algebra 2. So, find values of x where the function is discontinuous. Describe the type, infinite or removable. Justify your answer by using the definition of continuity. Okay. Thoughts on this problem? Three is an asymptote, right? Because when we set that denominator equal to 0, then we're going to get x basically cannot equal 3. And we know that is a vertical asymptote. What's the vocabulary we know for a vertical asymptote? Non-removable. Okay. So we know it's going to be non-removable. Because it's a vertical asymptote, it's also, what's the new word this year? Infinite discontinuity. Am I the only one that struggles to spell that word? Yes. That's why you hear me sound. If you hear me sounding something out like that, that's because I struggle to spell a little bit. So I really have to think it through. I can spell it. Just give me a moment. Now, we've used the vocabulary here. We found the value of x. Justified by using the definition of continuity. Okay. So we talked about there being an asymptote, right? And that's justifiable. But do you guys remember what this graph would look like? This is a graph you should be familiar with. There's an asymptote to the right, or at 3, yes. And then I worked with calculus in the past. I haven't really worked with pre-calc a whole lot about being able to graph this without grabbing your calculator. But I teach us in pre-calc or not? I'm trying to separate it out from calc in the past. But the idea that at an asymptote, generally our sign changes. Okay, so this graph, it's going to be our reciprocal graph. Do you remember the reciprocal graph? Where one piece is up here, the other piece is down there. But the idea of, unless x minus 3 is repeated, there's a repeated factor there, my graph changes signs at a vertical asymptote. So over here to the right, it was up positive, yes? So that means on the other side of the asymptote, my graph is negative. But this is also reciprocal graph. What else did we call it in pre-calc? It's second row, first spot. There's another name maybe we just talked about being a hyperbola. Maybe that's what else it was. But this is a graph to know, because this is the graph 1 over x shifted 3 right. Okay? And so, what's my proof here? The limit from the left does not equal the limit from the right. And so if we're talking about using the definition of continuity, that is your supporting factor there, is that the limit as x approaches 3 from the left of f of x does not equal the limit as x approaches 3 from the right of f of x. Okay. You could also use the fact that f of 3 is undefined, or as we talked about, D and E. For both of those reasons, we can talk about this fails the definition of continuity. And it's not even that you have to say both. As long as you can say one of them, you've got it. What about B? What do you think we should do to start this problem? Factor? Because as of right now, all we can do is set the denominator equal to 0. However, basically, my hint is I've got to show you a different type of example here, right? Now, I'm going to use this guess and check for a couple of different reasons. Follow with me my hints. 2x squared is easy to break up, right? 2x squared is going to break into 2x and x. Now, 6, it has a few options to break up. But if we're guessing it might cancel, one of my factors is likely going to be x plus 2. If this is a 2 right here, 2 times what is going to be the c value of 6? 2 times 3. Everybody multiplies and adds to be pluses, so those are pluses. That's my guessing. How do I check myself? I do a quick FOIL in my brain, yes? 2x squared, 4x, and 3x. Oh, hey, guess what? That's 7x. 3 times 2 is 6. Guess and check is not horrible if you have some clues to help you along the way. Okay? Now, am I saying guess and check is always easy? No, I'm not. I'm never going to claim that. But it is doable sometimes. And that to me was quicker than product of AC. Okay? Even if I have to check it. Now, what does this tell me here? What do we know? There's a hole, yes? Right there, because those cancel, we know x plus 2 equal to 0. So x cannot equal negative 2. Because it's a canceling factor we know is a hole, right? As I said, that goes back to algebra 2, technically. Pre-calc is where we hit it hard, though. Now, what about vocabulary for a hole? Okay, point to discontinuity. It is also what? Removable. Okay. So, in terms of definition of continuity. Sorry, my brain glitched out for a moment. Okay, how does this fail definition of continuity? Well, when we go to talk about g of negative 2, and we plug g of negative 2 into here, it doesn't work, does it? Okay, so g of negative 2 is undefined. Okay, yes, we could plug it in over here. However, that's just telling you where that hole is at, is what it ends up telling me. So right there, and I'm trying to try and throw in the word undefined because you often hear more undefined. I'm not disagreeing with does not exist, but same idea there. So that point is undefined. I mean, you can look at the limit from the left and the limit from the right. The limit from the left and the limit from the right do match up. But the key is we have a hole. Okay? So if I look at the limit as x approaches negative 2 from the left of g of x. Well, you're plugging the negative 2 in here, right? 2 times negative 2 is negative 4. Negative 4 plus 3, so I'm just plugging into what remains, so 2x plus 3, right, is negative 1. If I do the limit as x approaches negative 2 from the right, it's going to be the same thing. Because basically this graph is going to be the line 2x plus 3 with a hole on it. If you graph this graph, it's going to look like a line on your calculator. If you graph this rational graph, it's going to look like a line. If you really zoom in, you might be able to see the hole depending, right? So, and we can say the hole is, in case it matters to you, it's going to be at negative 2, negative 1. Okay, because that's the y value when x equals negative 2. But by definition of continuity, the limit as x approaches negative 2 of g of x does not equal g of negative 2. Okay. I feel like it's a lot, but I also feel like I'm repeating myself a lot, so hopefully it's sinking in. As we look at the next page, removing discontinuities. Using the definition of continuity to find the value of k so that the function is continuous. So using based what we know about the definition of continuity, limit from the left, limit from the right, equals the point in the middle, using that information to find k. So basically, assuming this is continuous, what is k? Or given that this is continuous, what is k? Okay. Now, as we look at A here, piecewise function, right? We've got a function for when we're coming from the left. We've got a function for where we're coming from the right, yes? So let's find these limits. So let's find the limit as x approaches. What is the key point? Where do we have to make this continuous? At 2. So we're going to look for the limit when x approaches 2 from the left. And I said of g of x, I'm going to replace that. Let me save myself. So I say g of x, but which piece of the function do I need to use here? If we're talking about as x approaches 2 from the left. We're using the kx squared, yes? So, algebraically, what is the limit as x approaches 2 from the left of kx squared? Okay, we plug the 2 in for x, because k is an unknown value. So we plug the 2 in for x. So this is k times 2 squared, which really equals 4k. So hold that thought. The limit from the left is 4k. Now let's do the limit as x approaches 2 from the right of g of x. But what piece of the equation can I sub in here? Kx minus 6. So if we sub that 2 in, 2 is going to go in place of x. And so this is going to become 2k minus 6. Well, what do we know? What should be happening? They should be equal, yes? So it's the idea that the limit from the left should equal the limit from the right, or in other words, 4k should equal 2k minus 6. Does that give us a way to find k? Yeah. Do your algebra. Subtract the 2k over And I have 2k equals negative 6, and thus k equals negative 3. Now, I'm trying to look at how I wrote my final answer here. Try and remember. I guess basically in the end, sorry, I'm trying to figure out what I wrote, and I'm having trouble reading my own handwriting. Sorry. Okay, I must have been tired when I was doing this one. Basically, we've done what we need to do. If we are going based on definition of continuity, you want to be official here, right? That's the key. If we want to be official, I mean, you've done the basics. That if G is continuous, we have to talk about, and I'm going to talk about real quick right here, I guess. What is the limit as x approaches 2 of g of x? So, and if this is continuous, right, all this has to match up. So, for instance, if we plug 2, okay, so knowing k is negative 3, and we plug it here into the left piece. So that's going to be negative 3 times 2 squared, which is 4, all equaling negative 12. So it's negative 12 from the left. If we do the right, negative 3 times 2, it's going to be negative 6, minus 6, which is negative 12. So we're getting negative 12 in both places. And does it equal negative 12 at that point? Well, at 2, what piece of the equation do we use? We use the top piece, which didn't we already come up with negative 12 there? Yeah. And so what we are able to say is that when x equals 2 and k equals negative 3, g of x is continuous. I'm not writing this in. G of x is continuous since g of 2 equals the limit as x approaches 2 of g of x, and which all of that equaled negative 12. Okay, again, all important pieces to mention. Did you have to mention all that to find k? No, but it's just putting all this continuity together. Okay. As we look at B, talking h of x, in order to find k, we have to look at the limits as x approaches 4. And so as we look at this, the limit as x approaches 4 from the left. Now, officially, that is the absolute value of x minus 4 over x minus 4. This is not one where I can just plug 4 in, is it? And hopefully you've realized that this is either going to simplify to be positive 1 or negative 1, depending on the situation. Well, yeah, positive 1 or negative 1. Oh, I misread my notes. Okay. Going 4 from the left, basically use something like 3.9, right? Or 3.999. 3.9 will deal here. Because 3.9 minus 4 is going to be negative 0.1, but the absolute value of that is positive 0.1. On bottom, 3.9 minus 4 is still going to be the same value, right? But it's going to be negative. And so, and I'll write this out. 3.9 minus 4, absolute value, over 3.9 minus 4. So there we have, nope. On top, because of absolute value, it's going to be positive 1/10. Divide by on bottom, it's going to be negative 1/10, which is negative 1. Basically, we've seen this a couple of times, haven't we? When the absolute value is on top and not on bottom, but you've got the same factor, it's either going to go to 1 or negative 1. If it's coming from the right, it's going to go to 1. If it's coming from the left, it's going to go to negative 1. Okay, so just kind of be aware there. Now, limit as x approaches 4 from the right. This one's easier, right? Because now we're using 5k minus 4x. And we plug the 4 in. We're going to have 5k minus 4 times 4, which is 16. So what do we know? We can set up the algebraic equation. 5k minus 16 equals negative 1. Add 16. 5k is 15. K is 3. Okay. If we know that k is 3, and you go back up here, 5 times 3 is 15, minus 16 is negative 1, isn't it? Okay, plugging it in. So we do know that the limit as x approaches 4 of h of x is negative 1 on both sides, and x is going to equal 4 on that right side, yes, which is just the same. So, when x equals 4, and k equals a positive 3 this time, h of x is continuous since h of 4 equals the limit as x approaches 4 of h of x, which all equals negative 1. Okay. I realize this lesson seems very repetitive. Although we're doing it in slightly different forms each time, right? Definitely feel like you should walk out if you're knowing continuity. Definitely. Okay, bottom. Given h of x is this lovely piecewise function. Note it has 3 parts instead of 2. For what values of x is h not continuous? And justify. Okay. First of all, one thing I do want to point out, each of those individual pieces, are they continuous in amongst themselves? And this is something to just be aware of. As in, negative 2x minus 5. If we just look at the graph, negative 2x minus 5, is that continuous? It's a line, yes? If we just look at the graph, 3. Y equals 3 technically is technically a line, right? I realize we're just talking about a point here, but it's a line, so that's continuous. Is x cubed minus 6x plus 3 continuous? Yeah, it's some kind of cubic graph. And here's the deal. Those are all polynomials. Just various, terms, added and subtracted, no funky division, no trig functions thrown in, no, just basics there. So you always want to realize that we need to be able to acknowledge that each piece here is continuous since they are all polynomials. So I'm going to even note that here. Each piece is continuous since they are each polynomials. Okay, so just, I don't know if that's something you necessarily have to state, but we need to acknowledge it. So, we go back to definition of continuity. Okay, because we're trying to figure out where is it not continuous. What is the point in question? Yeah, there's only one place this could possibly be not continuous at this point, and that is -2, right? So, if you go back to definition of continuity, let's look at this. The only place we could possibly be not continuous is at -2 where it's broken up. What is h of -2? 3, because it's defined to be 3, yes? That is this middle definition right here. So it is 3. Okay? What's the limit as h approaches -2 from the left? So what are we doing there? As h approaches -2 from the left, that is the 2x minus 5, which equals -1. Did I do my math right? Okay. Well, right there we already have an issue, don't we? I mean, that's, in our brains, we're stopping there. If I go one step farther, h of -2 from the right is using the x cubed minus 6x plus 3 feature. So that is -2 to the third minus 6 times -2 plus 3. -8 plus 12 is 4 plus 3 is 7. We've got another problem, don't we? This is not continuous in any way, shape, or form. Okay, we've just had 2 massive fails. So right there, when we start talking about step 3, the limit as h approaches -2 of h of x does not equal h of -2. The limit doesn't exist. Okay, so right here we can talk about the limit as x approaches -2 of h of x does not exist. And then the limit doesn't equal the point. So, conclusion? We were supposed to say for what values of x? H of x is not continuous at x equals -2. In my notes, I have a sample graph drawn, but I mean, the idea of a sample graph here is just, this is at -2, yes? At -2, 3, that's where the graph exists. The limit from the left is -1, so that's just saying the graph goes from there somewhere. The limit from the right is going to say that my graph is from there somewhere, right? Like, that's the idea of what we found. The point exists here, but the limit from the left to the limit from the right, 2 totally different things. So you could also think about being like a jump discontinuity. Okay, last page. Example 6. Shocker. Use the 3-part definition of continuity to create a system of equations, then find the values of a and b so that f of x is continuous for all real numbers. Okay. Well, what's the value we're going to have to work around? -1. So, what's the obvious equation we can go with here? At least obvious in my mind is limit from the left has to equal limit from the right, yes. I don't know, do I want to? I mean, we could go ahead. I don't think I did. When did I get to that? I got to it later. We could go ahead and state real quick. If we look at, just remember point 1, what is f of -1 equal to? 6. So that will be, we'll use that later. But what came to mind for me sooner was that limit from the left, limit from the right. So limit from the left as x approaches -1. And what are we using for the left? 2ax minus b. And I'm going to write this out differently this time. I'm going to go ahead and say it's equals the limit from the right as x approaches -1 from the right. And from the right, we're using ax squared plus b. To actually find these limits, remember that -1 goes in place of x. Easier for me to remember that this time. There's a and b. So in this first one, 2ax minus b. So what? -2a minus b. And the other one, -1 squared is going to be +1. And so we're going to have a plus b. I think that's not how I wanted to do it. Not exactly how I wanted to do it. Oh well. There's a reason I had it set up that way in my notes. Okay. Regret how I set that up, but that's all right. Okay, so the idea is we have this limit equals this, right? This limit equals this. Limit from the left equals limit from the right, which also equals what? This point of 6, yes? So, again, should have not the other way. If that is the case, then that means that -2a minus b has to equal what? Because right here, we can't really solve this, can we? We're going to get an a and a b no matter what we do. But -2a minus b is going to equal 6, as is a plus b is going to equal 6.
Why is it going to equal 6?
Because the point is defined to be 6. And my limit from the left, my limit from the right have to equal that point at 6, if this is continuous. Right? Okay. Those are the questions I need to hear, right? Okay. My algebra skills automatically tell me to eliminate. I don't know what your algebra skills do. Maybe they tell you to substitute. I don't know. I'm an eliminate girl. -2a plus a is -a. -b plus b cancels. 6 plus 6 is 12. And so a is -12. If a is -12, can you find b? Gosh darn it. If a plus b is 6, then -12 plus b equals 6, and so thus b is 18. I got it there. So, Find values for a of b that make this true. We're going to say a is negative 12, b is 18, and those are going to make it so that the limit equals the point. Okay, because ultimately, of course, that is the final goal, that the limit as x approaches negative 1 of f of x equals f at negative 1, right? And that is when a equals negative 12 and b equals 18. Okay. One more piece when we're ready. And I think I can do it. Got about 7 minutes left. I think that's plenty of time. We'll find out. But you know that the function value and the limit value can't exist independently of each other. Let's summarize the big ideas of continuity on intervals, at points, and one-side limits. So, given g of x, another piecewise function, find each of the following. So the limit as x approaches 3 from the left of g of x. What are you doing? Okay, we're doing the 2x plus 1. And so we're going to do 2 times 3 plus 1, which is 7. If my math is up to date. Never know. Okay. Easy enough, yes? B. The limit as x approaches 3 from the right. X squared, which means we're doing 3 squared, which is 9. Okay. G of 3. Okay, we're using, because on the bottom it says x squared and they're equal to 3. Because it says x squared and equal to 3, we're using the x squared portion, which means we're doing 3 squared again, which is 9. D, the limit as x approaches 3 of g of x. You have the information. Use your already done problems. What do we know based on our previous answers? It doesn't exist, right? This limit does not exist, and the short of it, because limit from the left does not equal limit from the right, or in other words, 7 does not equal 9, right?
So is that what we have to write? Or do we have to write out the whole limit?
Well, on this one, it doesn't ask, on this one it just says what's the limit. In my answer key right here, I have D and E. That's all I put in this box. Now, we're getting ready to explain in this next one. We're getting ready to pull it all together in this next one. But officially, the reason why officially is the limit as x approaches 3 from the left does not equal the limit as x approaches 3 from the right. You could do that, right? Is g of x continuous at x equals 3? Justify. What's that word? Justify. Here they ask for the limit. Can you technically just put D and E? Yes. Here they said justify. Can we just say yes or no? No, because it said justify. When they give those words justify, get official. That annoying stuff I've been writing out all period long. This is where you have to use it because it says justify. So, is it continuous? I wrote it. That's what you said, right?
Yeah.
Okay. No, it's not continuous, so I'm going to say no. G of x is not continuous at x equals 3. What's my justify? Okay. There's 2 options I could go with here. The limit as x approaches nope, it's positive 3, isn't it? 3 from the left of g of x does not equal the limit as x approaches 3 from the right of g of x. What's the other piece you could state?
Limit as x approaches 3 of g of x does not equal g of 3.
Right. The limit does not equal the point. So, as far as I'm concerned, both are very valid. You are both breaking the definition of continuity, so you have proved your point. So, I'm going to say ors, and I don't see that you have to put both, but you could say the limit as x approaches 3 of g of x does not equal g of 3. Okay? Summary. If a function is continuous at a point, then the function value and the limit value are the same at that point. If you walk out of here not knowing what continuity is, I don't know what to say. Maybe calc is not for you if you don't know what continuity is at this point, because man, I feel like I have driven this into the ground. So, okay, 1.6 for tomorrow, please.